My name is Kipkor Kidion from the Department of Medical Engineering, and my innovation is diagnosis of malaria using machine learning. Okay, where I was attached during the normal industrial attachment, I realized that most of the diagnosis of malaria is the use of conventional microscope, whereby the lab technician usually observe the prepared slide inside the microscope and then manually checking the microscope to see where there is virus, not the virus but the bacteria. But I realized that there is need to innovate in order to solve the problem of manually checking the slide by using machine learning. So I realized that there is need to capture those images, and these images is trained using machine learning. And then once the model has been trained, then the model is extracted, and then later I build the software. And this software is able to detect the presence of malaria, not only the presence of malaria, but to an extent which type of malaria, because we have 5 types of malaria. And this system is able to detect the presence of 2 types of malaria. That is the Plasmodium falciparum, which is the common one, and we also have Plasmodium falciparum. So I realized that once you train a model, it will be able to avoid the biasness, because as human beings sometimes we are biased, because they normally say experience is something very important in anything, because if you have experience, definitely you are able to identify, to spot where there is bacteria. But computer is not biased. So once you train the model, it will be able to learn through patterns, because it will be following a particular pattern. So once the computer has trained and is able to identify those patterns, it will be able to tell you which type of parasite, that is either falciparum or the fifax. Because for the falciparum, it is the one which is so much intense. At the same time, the shape of the shape inside the slide is banana shape. So the computer is able to identify which type of parasite, because it will see the pattern. If it is banana shape, it is able to see that pattern, and it will be able to show that this is a type of malaria, that is Plasmodium falciparum. So with that, I can demonstrate how the model works. Okay, so someone will be using this software should be able to create an account. Then you log in with the normal details like the username and the password. So I'm just creating a simple account. And then it will be able, in case you forget password, it will be able, you are able to reset the password. So first of all, when you are creating an account, you have to enter the security question, because most of the softwares, in case you forget password, you are supposed to reset it back. And for you to reset it back, you should be having the security question. So I'm just setting my security question. So which town were you born in? Let me just say my town. And then we also have the product key, because even for the Microsoft, for the Windows, we should be having the product key in order to activate the Windows. So for me, I'm also supposed to provide the product key. Then once you click sign in, you are able to log in. So let me just log in with the account that I created. So once you log in, anybody who will be using this software, because once you log in, meaning that you have the credentials, then you have to enter the patient's details, because patient details, in order to be saved into the database, so you should be having the patient's details. Like, let me say the patient is my name. And then age, we have using the first name, other name, and the gender. And then you save the record. And then once you save the record, it will take you to a different window whereby you are supposed to open where there is those images. So I'm just clicking open folder, and I'm supposed to view those images, because once the images has been taken, it will be saved into different folders depending on the patient details. So I'm just clicking where those images are. So let me just click the first one, because I have a set of images. So let me just choose any image. And then once I load the image, the software is able to detect. And you just have to click a button. So once you click a button, it will be able to show you where the details of the patient and the status and accuracy. And according to this prediction, the status is Plasmodium falciparum, and the accuracy is 100%. So once I predict, or the system predicts, you just have to upload the records, because maybe in the near future you'll be using those records to make a clinical decision. So you just have to upload, and then in case you want to upload another image, this time around, let me just choose an image which is not infected, because inside here I have two sets of images. We have the one which is infected and the one which is not infected. So let me just use images which are not infected. And then I upload to the software. The software is able to detect. And this one, the status is uninfected, and then the accuracy is 97.142%. So once you make diagnosis, you can upload to the database. And then in case you now want to make the clinic, because you'll be performing a set of diagnoses. Now you want to see which image was having this malaria and which one was not having malaria. So you just have to query the database, because everything is saved to the database. So you just have to click a button, and it will be able to show you all the diagnoses that you made. Like, since we made 2 diagnoses, the first one is Plasmodium falciparum, that is 100% accuracy. The second one is 97%, but it is uninfected. So this software will be aiding the medical lab technicians. Instead of manually checking through the microscope, the software is able to make all those diagnoses. It will be able to see these patterns, and it will be able to diagnose. And this software is very important, because as you can see, with technology, there is prospects of using AI. And AI is something, it will be replacing human intelligence, because we have artificial intelligence and we also have human intelligence. So this artificial intelligence will be trying to mimic how human brains work. Because in order for you to make a decision, you should be having something inside your brain, like the pre-knowledge. And this pre-knowledge is what artificial intelligence is trying to mimic. I believe with this software is able to make accurate diagnosis, because it will avoid biasness, and it is very, very important. Thank you.